Alright, so we already have router 1 and router 2 configured according to the Chapter 2 lab. We took a brief pause and we want to implement the optimized single area configuration stuff. So it says on router 1, configure the interface for OSPF priority to 50 to ensure it becomes the designated router. So we're going to reverse router 2 with a higher router ID and make router 1. So let's go to router 1, configure terminal. We're going to do interface GI0/1. We're going to do it OSPF priority command. $50. So that should take care of A. Remember, it's not going to just quickly pop over there. It says Gigabit 0 of each router for hello timers of 30 seconds. IP, OSPF, hello, 30. The previous question mark command shows you all the different change cost and intervals hellos. We can add encryption. I wanted us to do that on router 2 as well. So let's do a big T, interface, GI0/1, IP OSPF, hello, 3. We didn't do the priority on that one because it was only supposed to happen on the router 1. You can also see that some things changed because of the hello timers didn't match before. We've gone down and now we're back up. Alright, configure default static route on router 1 using the loopback and propagate that through OSPF. Alright, so that's going to be the default information originate command. And we're going to use route statement. So we're going to go IP route 0.0.0.0, 0.0.0.0. It says to send it out loopback 1. Boom. We're going to get a message. I believe it says somewhere in here we're supposed to get a message. Yep, note the console message about the default route. So we're good there. And it said it wanted us to propagate it. So we got to go to router OSPF. We use process 56. We got to do the default information originate command. So on router 2 only, set the loopback 1 as a point-to-point. Okay. Let's go exit. Interface LO1. So I was using a question mark so you could see on this, instead of using the priority commands, we're using the network. We're setting the type to point-to-point. All right, on router 2 only, add the configuration necessary to prevent OSPF advertisements from being sent to loopback 1. Alright, so you would go from here to the router OSPF 56. Yeah. We go passive interface command. It says change the reference bandwidth for each router to 1 gigabits. So I think it's done in megs, so it'll be 1,000. So let's see here, I think it's a reference bandwidth. the auto cost. Reference. It's a megabit, so it's going to be 1,000 to get it a gig. We're going to change that on both routers. Auto cost, reference, 1,000. So that should take care of that part right there. So let's restart OSPF using the clear command. So let's exit out of here, both of these things. Let's do a clear. Well, for that, let's copy, run, start. Let's make sure we got our config saved. So versus rebooting, now this is not advisable. In the real world, because we may have a lot of information in here. It may take a long time to recalculate stuff. Plus, it's going to take your network down, or it can't route until it relearns. So you may not want to do this, or definitely not reboot. In the middle of the day, you do it non-working hours. All right, so you can see that everything's loaded back to full. So how did our routing table change? We got a loop back in static address, right? We got a default route. We'll reload. All right, so we want to do show IP interface Gigabit 0 command so we can see that the priorities have been set. We had changed dead interval. Must have missed that statement. Oh, it auto changed because we changed to 30 and the dead intervals 4 times, whatever the hello is. Run table metric between this output, previous output. The mask is now 24 bits as opposed to 32. Once the default route's propagating, we should be able to ping. Let's see. Waiting for it. All right. We have our O route. We've got external route. So you will get an E2 external route when we've propagated a. So you can see if I'm pinging something that I don't know where it's at. So for example, 42, which it won't go there because we don't have a real internet connection. It will get forwarded over to 1053 and onto the loopback, but it'll never go anywhere because we don't have a real connection to the internet. But you can see that the default route's working. As I said, go to 422. That's not in my routing table. There's no 4s here. But we don't know where that is supposed to go. All we can do is send it to our default route, which is router 1. We did go to router 1. Control Shift 6 to kill it. see here, they wanted us to do a show IP OSPF interface on Gigabit 0 on router 1 so that we could verify our time intervals have changed. So you can see our hello timer has changed. We already checked all the routes. And yes, we can ping. Should do the same on router 2. That router's interface. Let's say 16.1.1. So we can ping both directions, both loopbacks, thanks to OSPF. If you've done all this successfully, you've completed the lab, and you know how to configure single area OSPF and troubleshoot.